Okay, so section 7.1. Today we're going to talk about graphing inequalities. So we're going to talk a little bit about what it means to graph an inequality. It's a little bit different than graphing a line. There's some shading involved, and when I get back and we start the next lesson, I'll get out the colored pencils and we can use that for our shading. But for today, we're just going to use our pencil because we only need one color. So with graphing inequalities, it's much like graphing a line. We have to do the same things. We have to solve for y, know the slope, know the y-intercept. It's just going to, a couple different things that will change. So I'm going to walk you through all of that. So go ahead and turn to page 476, which is my next page. We're going to do problem 1, and we're cranking it up for the playoffs. Okay, so, number 1 says, Coach Purvis is analyzing the scoring patterns of a few players on his basketball team. Bina has been averaging 20 points per game from scoring on 2-point and 3-point shots. So question A says, if she scores 6 2-point shots and 2 3-point shots, will she meet her points per game average? So we want the average to be 20. So we want to know if she scores 6 shots worth 2 points and 2 shots worth 3 points, how many points will that be? Well, 6 times 2 is 12, plus 2 times 3 is 6, so that's 18 points. Does she meet her average of 20? No. She scores 7 2-point shots and 2 3-point shots. 7 worth 2, plus 2 worth 3. That will give her 14 plus 6. So, yes, she will meet it. Last one, go ahead and try that one. I'll write it up here. Okay, so I got that she would score 26 points. And yes, she would meet her goal. She would even be above that average that she wants. Number 2 says to write an equation that to represent the number of 2-point shots and the number of 3-point shots that total 20 points. So if we let x be our number of 2 points shots, and we let y be our number of 3-point shots, then our equation would be 2x, 2 points per 2-pointer, plus 3y, 3 points per 3-pointer, and we want that to equal 20. Number 3 says to graph that. Now remember, we cannot graph anything unless it is in y equals. So we need to take this and change it into slope-intercept form, y equals form. Subtract the 2x. That leaves you with 3y equals 20 minus 2x. Then we have to divide everything by 3. Leaves me with y equals 20 over 3, that won't reduce anymore, minus 2/3 x. Okay? Of course, they're not very pretty numbers, but we're just going to roll with it. So my x-axis is my number of 2-pointers. My y is my number of 3-pointers. And we are just going to count by ones. Let's put this in y equals and try to find some good points. So we've got alpha y equals enter. 20 over 3 minus alpha y equals enter 2 over 3x. Okay? Ooh, 1, 6. That'll be a good point. So let's go ahead and do that. Let's label 1, 2, 3, 4, 5, 6. 1. We can keep going. 7, 8, 9, 10. 5, 6, 7, 8, 9, 10, and 1, 6 is a good solid point. See if anything else. 4, 4 is a good solid point. 7, 2. And we will get one more. 10, 0. Perfect. Okay. That will be our line that represents her getting 20 points. Okay, so we're going to come back to this, so keep this page handy. On the next page, Coach Purvis believes that Danvers High School can win the district playoff if Bina scores at least 20 points per game. How can you rewrite this equation you wrote in question 2, so the one we just graphed, to represent her scoring at least 20 points per game? So now this is when we're going to use our inequality. So if 2x plus 3y represents the points that she makes, and we want at least 20, do we want the points that she makes to be greater than 20 or less than 20? Well, greater than or equal to. We'd be okay with her scoring equal to 20 points, but we want 20 points or more. So I'm going to use a greater than or equal to. And we've done that a couple chapters ago. It's been a little while, but at least is one of those words that lets us know we need to use inequality. So they talk about our inequality symbols here: less than or equal to, greater than or equal to, and then they just kind of write the different time, using the different signs, what it might look at. So let's skip to number 5 and complete the table of values. So let's assume that she makes 4 2-pointers and 1 3-pointer. How many total points would she make? Well, 4 times 2 is 8, plus 1 times 3 is 11. Okay, so does she make her goal there? Not quite. What if she makes 6 2-pointers and 1 3-pointer? 6 times 2 is 12, plus 1 times 3 is 15. 7 2-pointers and 1 3-pointer, that'll be 14, plus 3, 17. Still not quite at that goal. If she makes 8 2-pointers, so that's 16 points, plus 2 3-pointers, so that's 6 points, we end up at 22. Keep going. 6 2-pointers and 4 3-pointers would give her 24 points, so she's making the goal there. 9 2-pointers and 5 3-pointers would give her 33 points, so she's well above there. Okay, so I just fill that in, just multiplying the number of 2-pointers times 2, 3-pointers times 3. Number 6 is to use the data given in the table to plot these ordered pairs. So let's assume that these are 2-pointers, so that will be X. These are 3-pointers, so that will be Y. Let's plot them on the graph that we just did. If the number of total points scored does not exceed her points per game average, so if the number over here is not 20, we're going to put an X to plot. Okay, so where are X's going to be? Well, this one's not 20, this one's not 20, this one's not 20. If the total number of points meets or exceeds, we're going to use a dot. Well, this exceeds, and this exceeds. So we're going to go ahead and put dots there. So now I'm going to go plot these points. So the first one I'm going to do is 0.41. So that is 4, 1. And I didn't make it, so I'm going to give it an X. Okay? Next one, there's the table, sorry. Next one I'm going to do is 6, 1, which I'm going to give an X because it did not make her average. And then 7, 1, X because not there, not enough. Now I've got the 0.82, which did, so I'm going to give it a dot. I have the 0.64, which did, and the 0.95. Okay, so all of these dots, these made her goal, these did not, these X's. Okay, so what do we notice about the graph? Well, the X's are below the line. So the X's are below the line. So this is when she doesn't reach goal. When she doesn't reach 20. The dots are above the line. and this is when she scores more than 20. And the placement below or above is really important when we are graphing inequalities because that's going to determine where we shade. So the reason why we shade with an inequality is because inequalities, you can have more than one answer. There's more than one combination of points that are going to get her greater than or equal to 20. Obviously, we have 3 right here that make her have more than those points. So we can't just graph the line and be done because there's many more combinations that we can have to get her either greater than 20 or less than 20. So the placement of where these X's and dots are, so again, the X's are below the line, the dots are above the line, and that's going to tell us how we shade. So go ahead and flip to the next page, which we might need to go back to our graph again. We will see. So number 8 says, what can you interpret about the solutions of an inequality from the graph? So what we can interpret is that any point above the graph means that she scored more than 20 points. Okay? So these points up here were when she scored like 22 and 33 and what was the other one? 24 points. So this means that she's gotten more than 20 points when we're above the line. Now on the line would be the combinations of exactly 20 points. So if she wants to reach her goal, she's got to be on this line or higher. So let's write that. On line makes exactly 20 points. So this would take care of that equal to part. Number 9 we're not going to do. We're going to go to number 10. It says shade the side of the graph that contains the combinations of shots that are greater than, or equal to her average. Well, like we said, on the line would be the equal to part, and anything above the line would take care of the greater than. So what we're going to do is we're going to shade, just with your pencil, shade this part of the graph. Okay, so this means that anywhere in the shading is going to give her that at least 20 points. 20 points here, anything above that is in the shading. So there's more than one answer, which is why we have to take care of that shading. Okay, so shade that, don't take forever. And then number 11 says how do they differ from, how do the solutions of 2x plus 3y equal 20 differ from the solutions of 2x plus 3y greater than or equal to 20? Well, kind of like what I just said. This is only the points that equal 20. So only equal 20. This is the points that are 20 or above. Okay, so there's a lot more of these. And then number 12 says, does the ordered pair 6.5, 5.5 make sense as a solution? Well, are you going to score 6.5 2-pointers or 5.5 3-pointers? No, this isn't going to work because we're talking about a basketball game. So no, this doesn't make sense. Okay, so you've just graphed your first inequality. Congratulations. It's much like graphing a line. You just get to color on it, so that's exciting. Okay,